Do you remember this is so-called 32 bytes? Okay, 32 bytes. Remember, they have 32 bytes. 32 bytes are data type, okay, which today's tutorial will give you the C code of this structure. We call it directory entry. Okay, so you'll find two structures in the tutorials of this week. One structure is the boot setter, containing all the information about a file system. Another is this boot setter. And our directory entry. Our case will also carry about an alignment problem, how to get rid of the alignment problem about these fields. Okay. So he'll talk about it. I don't worry about that. The last topic that, well, not last point that we stop about this directory entry is about the file size, right? The file size is the bad guy. How bad it is? It's limited. First of all, we have 4 bytes only, okay, and that's why we have 2 to the power 32 variations, and you can do some calculations. It means that the largest value that it can store is 4 gigabytes minus 1. Yeah. I mean, 20 years ago, this is a big number. Okay, nowadays it is a small number. 4 GB. I spend less than 10 minutes, I can transfer it. Okay. I don't know whether it's okay on Wi-Fi or USB 2.0. Okay, but 10 minutes is enough. Now, how about other file systems? Other file systems already know about this. So they extend this field, okay? Although their structure may not look like this, but they reserve more bytes now. They reserve at least 8 bytes. So we 2 to the power, what's that, 8 bytes? 8 times 8 is 64, okay? The 2 to the power 64, okay, variation. So it should be enough in the coming 100 years. Okay, I hope that we still have computer today. So what's the next guy? Next guy is a horrible guy. Okay, so how horrible it is, I need to draw it out. Okay, now first of all, this is a great invention from Bill Gates again. Okay, then you see how great it is, right? Bill Gates. So we have a I directory entry. Okay, I said it's 32 bytes long. Okay, so last time I already tried in front of the class that I create an entry, and you can find the name like this. Okay, hiding here as A, B, C, it is a TXT. Okay, for extension port. So it's hiding in this 32 bytes. No problem, it's understandable. So you create one more file, and when you create a file, you will create the directory entries as well as data blocks. Okay, so I did, yeah. Nothing. Okay. And yeah. All right. Then we have next. Oh, what happened? Okay. Next one. If because of this thing. Should we? Yes. Who make this one? Who make this one? Also 32 bytes. Okay, so then will be the next directory entry. So the 2 directory entries go side by side. Now what happens if you create a file name which is long? What is the meaning of long? Hello, okay, .docx. Okay? So the extension goes beyond the 3 bytes limitation. So in Bill Gates' mind, okay, he have a great invention. Really great, okay? Have you ever seen a file name look like this? Should be 6 guy. Let's say hello world. Yeah, have you ever see some file name look like this? Yeah, if you're old enough. Okay, yeah, I see two. Then these guys are old enough. Others not old enough, that's good because that means you're young, right? Yeah, but this don't convert into any knowledge, right? I now convert it into your knowledge, right? I hope that we enter become some wisdom that you try your improve the file system. Okay? So what is that guy? This guy is what we call the normal or the short file name of another file. Let's say that another file is like this. .txt. Okay, that's it. We have file name called power.txt. So it will pick the leading 6 guy, 1, 2, 3, 4, 5, 6. Okay, the leading 6 guy, and copy it to the what we call the normal entry. The normal entry. Okay, and the normal entry, take the 6, y 6, it leaves the next 2 bytes become tutor 1. Okay? And this is the normal entry conversion from the normal file name. But you know, a file system shouldn't do this, right? You rename a file actually, right? You rename that file and put it in a normal entry. You should find a space to store this long entry, right? We call it long file name. Where is a long file name? Where is this entry? Very interesting. I said that we have an entry, let's say this guy is an IM entry. So when you want to store the long file name, when you type the long file name, and type a VI, okay, and want to save it, then it will create, actually, it's not reverse order. You will first create the n-1 entry to put the long file name only. Yeah, interesting. That's the beauty of communication. It's just reverse the game, okay? You know, he likes to reverse the game. So he created I-1 without any useful data, just the name. Okay? And then created I1 to store the normal entry. And that's all. So when you take a look at my PowerPoint, it will be a little bit hard to understand because I don't show you the creation. Okay? The creation is like this, okay? If your long file name is really long, okay? What is the support limit? The support limit of the long file name, of course, it supports nowadays with a character type. Okay, it will support a Boolean code. Okay, usually when you use Boolean code, you support Chinese, you support we call it CJK, Chinese, Japanese, Korean. Okay, so the CJK support usually 2 bytes per character. Okay, so then it supports more than that. And imagine that if I allow you to input 255 bytes for that long file name, you can host it in a long file name structure because the long file structure is again 32 bytes. It's again 32 bytes. So you will have multiple of it. And now this is another build case. The way to read it is, here's the I-1, I-2, I-3. You read it in reverse order. Okay? So how do you imagine that the creation is like this, okay? You know that it needs to allocate 3 long file name entry. So it will first allocate 1, 2, 3 as well as the normal entry in the directory. I'm not talking about end data. In the directory first. So the directory saving your file name, file size, leading customer address, all in the normal entry. And how about the name? Do it in reverse. Okay? So I have a screen capture with colors. Okay? So what is this file? This file is supposed to be, I know the operating system post.txt. Yeah, long enough, right? Then where can you find the data? This is normal entry. I said it will pick the leading 6 character. So leading 6 characters is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 2 to 1. And then txt. Okay, so this is capture of txt. And you need to store this guy, right? Where is those characters are? They're here. And look, I don't know what is it. The love person, he is here, okay? He is here. Operating system, the OP is here. And you see this is just reverse order, okay? And you will have a question that, hey, why this course is broken into pieces? Okay? So let's take a look at how Bill Gates, I don't know what's only Bill Gates' decision, okay? And his team, okay? Bill Gates and his team sucks. So they do this. This is normal entry. So they borrow the normal entry structure. Borrow it means that you will also again use 32 bytes. Okay, so 32 to 32, and they just try to abuse those fields. So what are the fields that they want to abuse? They want to abuse the file name part. Okay, the file name will have how many bytes here? 8 plus how many? 3. I said 7. Why I said 7? Because the leading one is here. Okay, so it actually is 8 plus 3 together with the file name. So it's abused that the leading part with a sequence number. So what is the sequence number? Let's take a look at data. Sequence number. This is the sequence number 1. So that means that there's a long sequence, right? Here's the first piece, second piece, and what is this 43 piece? Okay. They know I tell you why it's 43. Okay. Then abuse this area. So we have 5 bytes, 5 characters, why 5 characters? Originally we have 10 bytes, but you want to support Unicode. Okay? So you will set every 2 characters to be 1 character. Okay? So let's say you are using ASCII code only. ASCII code only use 1 byte, you know. Make sure you know what that. I teach you Unicode in other classes, and I should say that only if you can't talk about something. Okay, so if you don't understand what Unicode, just treat it as 2 bytes. But ASCII code, it should be known by all people, right? The ASCII code is 1 byte. So what should we do during the time that you say the ASCII code? It will use 2 bytes. How to read it is 0049. So to keep the remember this is a little endian, so you read it from another way. Okay. So you will set the most significant bytes to be 0, and the content is here. So 49, you can do a man. Okay. Do you understand what I mean? Do a man. Okay. Man. You don't know there is an ASCII table in our system. Man ASCII. Yeah, you don't need to go to Google. Oh, interesting. 新奇咧. Okay. 49 has a decimal 49. It's I. Okay. Yeah, you don't need to do Google. You know, it's all man ASCII. Okay. So that's why I say go to man. Okay. I mean, go to man ASCII. So you can find out that Unicode with the leading or the most significant byte becomes 0. So when you read it, 2 by 2, 2 by 2, so it's 0049, 005F, okay, so and so forth. Now this is not hard. Most people can do it, but well, it is not always continuous. I write down some of the white area there. So what are the white area? The white area is because we are abusing the structure and we want to destroy the structure. So for this field, the file attribute fields, to identify this file is a directory, regular file, or some other things, we cannot use it, so we keep it there and create a new value called COF to represent that this entry is to represent LFM, long-file name structure. Okay? So this is something that you have to know in assignment 2 as well, because I don't know maybe our tutor or even yourself create a file and wrongly have a long file name created. So your program may need to skip those entries. Okay? So the skip, whenever you find this is 12, then it's start with 0. The 12 bytes is still F. Alright, so you will see it's broken in pieces, another piece here. The last piece, there are 4 bytes in the file size area. So you will create 2 Unicode characters. So we break into 3 parts for every entries. Now you will see this 3 parts, the green part, the orange part, and this pink. Okay, in my monitor it's a pink, okay? Here it's a little bit strange. So this is it. Now, how about the last guy? The last guy, it uses a stupid notation. It's a very stupid thing. The stupid notation is, I don't know whether this is the end of the entry. Okay? So you can still look at the sequence number 1, 2. This is supposed to be 3, but why is it not 43? It uses bitwise or force 0 to that entry in order to mark it this is the end. Okay? So just remember that, oh, you see 4 there, it's means the end. That's all. Okay? So it will become very interesting. You know what is 43? 43 here. 43. It is C. Okay? So when you look at it using SSD, you will find a C there. Okay? Or this long file name only uses 1 entry, so you will find an A. Okay? Only 1 entry and then it's N. So you will 41. So there's A and B and C. So later on, when you do assignment 2, you create non-file name by accident, you will see some A, B, C, D, E, F, okay, all scattered in leading bytes. And that is so happen to be the ending sequence number. Okay? So you can treat it as 1 to 3. It's only that how can I describe it? Okay. Second bit, okay? Second bit is the turn on, okay? Yeah, it's very hard to cut. So when it combined together, the long file name structure is like this. So that's why I know this is just a piece of tedious work, okay? But after I talked with our TA, we think that it is quite tedious. You can always do it, give you more time, you can do it, okay? But we don't have too much time, so we remove the support of the long file name, yeah, just because of the thing that it can eventually be done, right? Okay, so why not remove it? And this is the thing, and the short summary here is, remember, we didn't talk about anything yet, okay? We only talk about directory. Whenever you create a file, you copy a file from another folder, you copy to your FAT32 folder, you will create a directory entry, and directory entry contains too many important things, okay? And eventually it will go to the data part, okay? Because you try to read it. And remember, let me go back to this page. This is the FAT1, this is FAT2, and once after the FAT area, we will start the data area. And remember, root directory is always a part of data. Don't treat it as a so special that, oh, it should be outside the data area. No, it is a part of data area. And this type of directory cluster, or a block for directory, will always cut into a 32 byte size array. Okay, it's just an array 32 bytes, and you will find it nicely aligned, especially when you're really using XC. Okay, so remember, this is something that you have to know. And any question we'll ask, yeah, this is something that no intelligence there, just some pure facts, okay? And the facts is Microsoft size, okay? Again, I said that we only tell you about directory. We never tell you about data, right? Now we touch the data. You go to read it, go to write it, okay? So when you go to read it and write it, now the data cluster comes into play. And remember, whenever you find a cluster, cluster is just a block, okay? The first cluster is always start with 2 in Microsoft, okay? Not just Microsoft. This part everything 32, okay? Microsoft say that 2 is the leading one. So every manufacturer, no matter if it's your camera, your iPhone, your Android, all have support this. 2 is the start, okay? And then whenever I write just a random cluster number, I really mean the number, the address is 32. I don't mean that it is a 30-second cluster. Okay, if it's 30 seconds, then you have to adjust back. Okay, so this is a pure cluster number I want to say. Now, what this figure is about? This figure is about, let's say we're doing something crazy. How crazy it is, there's XPST file Explorer.ext Windows. I want to read it. Yeah, no problem. I just open it using VI or using Notepad++. Okay, you open it and you read some Martian language there. Now, how do you read it in terms of file system operations? So you have to put your position as a Linux kernel or a Windows kernel. Now you are the kernel. You only know this layout. You only know this layout. And some of the information already get from this boot center. You know where the FAT slot. You know where the root directory slot. Now that's all for what you know. Okay? And by the directory transversal, let's say you already know that, oh, the C drive, the root directory, contains a subdirectory called Windows. And what's next? Next, you should follow the Windows directory. If there is a leading cluster number, maybe I go back to page because it's a continuation of the story. Okay, why is it so slow? Okay. So there's a custom number 2, you read it, you want to find out Windows, okay? And Windows say that my leading customer, this is linked list, right? This is the first customer, or I say this is leading customer address. Start with 1, 2, 3. So what you do, you will go to the here, this area, to find that 1, 2, 3 out and read it to process this array of a 32 byte structure. Okay, so the cartoon adjusts a bit. Remember, suppose this is a 1, 2, 3, okay? And then we continue the story of reading data. Okay? So when you try to read the data, you will follow the linked list and you read it all. The first guy is 32. So while you're reading, you will go to the data cluster area, position the address called 32, pull the entire box out. Okay, pull the entire box out, and while you're pulling it out, you have to read this attributes because you need to know the file size. The file size determines whether you should stop the reading or not, right? Let's say your file size is 1 byte, and 1 cluster is enough. Okay, let's say that it's not 1 byte anymore; it's 10 megabytes. Okay, so you have to follow the linked list now. And how can you follow the linked list? Last lecture, I talked about this area may be already put in the system memory. So I don't consider that as a disk, okay? It's already in the memory. Let's say it's in the memory layout. I align it as an array. The gray area here is address. So the array slot 0, array slot 1, array slot n, so on and so forth. And every address we assume it to be 4 bytes. Okay? So now we are reading 4 byte by 4 byte, and while we are positioning to the address of 32, okay, so the array 32 gives you another number, and that number is the next cluster of 32. So when you will read it out from memory, you are the kernel, remember you are the kernel. So you are the kernel, read out the 33 and go to this data area, pull out the 33. Address 33, okay? Address 33 block, pull it out, and return to the user. Okay? So this is easy, right? The reading is easy. You just follow the linked list, and when should you stop? Let's say you keep on following it and find another entry. Oh, I need this table, okay? Find another entry called EOF. So why you find EOF? Because you read 32 and then you hit 33. While you finish reading 33, the data area, you go to this array and go to the 33 here and find EOF. So what is EOF? In FAT32, they don't use a 0 to represent a null pointer. 0 means unallocated, not allocated slots like this. Okay, it's not allocated, it's not allocated. And EOF is use a range of, I don't know why they need a range, right? A range of representation. So with this range, it means EOF. Okay? So far so good. If you have any question, stop me immediately. Okay? And that's why you will understand that why I always say that FAT32 can use up to 28 bits. Take a look here. Then you understand why it's 28 bits. Right? Only 28 bits close to the true range. Okay? Only 28 bits can use to represent an address, and it leaves the leading 4 bits. I pointed wrong. Okay? Yeah, very hard to point. Okay, you can hear. Yeah. The leading 4 bit, okay, you cannot touch. Because when you touch it, it means EOF, okay? So I don't know why they're doing so, but you forget about this. The EOF representation now means the end of the linked list, and usually if your file system is in a consistent state, what is consistent? The consistent state means that you reach this EOF cluster, you will only read up to the file size modulo your cluster size. Understand what I mean? Remainder, right? You divide the block size and get the remainder of the file size, and it's the remainder in here. If your file system is in an inconsistent state, that means I don't know under what kind of damage, okay? This file size stores some strange number, and although you reach a EOF cluster, it's still that, yeah, give you more, okay? Then the file system will throw some error, okay? And later on, or not later on, okay, only in the class, okay? In the class, I will tell you how to write such a file consistency check software to detect so all kinds of anomalies, okay, of file system. Okay? So suppose that the file system is in a good shape, then we will go on and reach EOF and stop the reading. And the reading part is very easy, right? Because you don't change the file system. You just being a read-only guy. Now we try to write something. What is the writing? Let's say we are crazy, okay? And don't do this. I want to append something to this file. And don't do this, okay? You can try, no problem. Unless you don't want to write Windows. You don't know what I'm doing here? Do you know what is Explorer.exe, huh? Yeah, if you don't know, yeah, I give you a text, okay? And after this text, you will know what it is. Delete it. Delete it. Then you will understand, okay, I know this is important. Yeah. And yeah, welcome to the Linux or Mac first, right? Yeah, you don't want to use Windows again, right? So this is a crazy stuff, don't do this, okay? But I just want you to have an illustration, okay? Suppose that because of the previous we know the structure, okay? We know the structure that the end of the cluster is a 33, okay? 33, no next cluster, no next, okay? And what should you do if you go into append data? Again, I say that this cluster 33, suppose in this area, may not be fully filled. It depends on the remainder when you divide the file size with the cluster size. Divide it and then you get the remainder. And let's say the remainder is not 0. The remainder is 0 means what? Two cases. Either I don't know why, inconsistent, right? You allocate it and without anything there, or fully filled. Okay? So let's say it's not fully filled, you keep on filling, and then you find out, I fully filled the cluster. What should you do next? Allocation. So where can you find any allocation information? During I talk about this, guys, this whole range, I never talk about how to allocate blocks. Now, this is something new. To allocate the block, we will touch this area that I never say anything about this. Okay? This FS info is what we call a file system free space management unit, or data. Okay? Free space management data. And data is to save two important information. How many free clusters in your system, as well as what is the next available free cluster that the system thinks that you should have. Okay? So later on, I will tell you why we need to save this. Okay? So let's continue the journey. So the journey is like this. I know that because of the free space management structure, the free space management structure does tell me that I still have free space in my system. We've got 4 free clusters. And the next available cluster that the system knows is 34. So 34, 0. So I'm allocated good. I will allocate it by saying what? By saying that I will set this guy to EOF, first of all, because it's become my end of the linked list. And how about this EOF? What should it be? What should it be? How do you update it? 34, right. It becomes the next address, okay? So you will update it like this, and update this 2 guys. Now, how to update this guy? Why is this 35? This is by luck, okay? Yeah, this is something that I want to tell you is about the extra things, okay? Because this course supposed have to teach it, but if I teach it, it will become very boring course, okay? We have 2 heuristics, okay? That's not something always true. The 2 heuristics, one is called temporal locality, means when you with something, temporal means across the time, okay? When you use something, then you will be very likely to visit that area or that data again. So we call temporal locality, it means time. So that's why we will have a memory cache to deal with this temporal locality. And also we have another observation from operating system study is spatial locality. So spatial means space. So what is the meaning of spatial locality is that when you read something like address X, with a very high probability, you will also have x minus 1 or x plus 1 So that is this area, alongside of that, you will try to read it also, okay? Maybe by a very high chance, okay? Just a chance. So I said it's a heuristic, not an algorithm, not something always true, okay? So based on this heuristic, the spatial locality heuristic, we will do the following way. If I allocate something here, I will hope to allocate its next address, so as to strengthen, okay, to strengthen the spatial locality effect, okay. When you try to read it and you try to continue to read it, also because your media may be a mechanical media, you are spinning, okay. So when it's during the spinning time, I allow you to read the file in a continuous way. That will be the best, okay. So it will do this. Continue to have a circular search, starting from your previous allocation. Go to search why is a circular, very easy. I want to squeeze out all the file system space, okay? So if I fail to search, look for a free space here, I will go back and do a circular search. Suppose that this free cluster is true, okay? Then I will eventually find a free cluster, okay? So this is the way to scan it, okay? Now we'll allocate this guy and change this to, what should we do next? Fill the data, right? Fill the data inside of this, and that's all. It is the write. Okay, so you should write it slow because write involves several guys. The first guy, you have to update the FAT, and usually when you update the FAT in the memory, you have to flush the change to the disk, right? You make it persistent. And second, you have to update MS info. Next, because you always have to find the next available cluster, eventually in the worst case, you have to scan it and plot this. Okay? So the write is usually much slower than the read. Okay, the read is easy, right? Just read only. Okay, the write, you have to scan. You have to update, you have to seek the diskette. Okay? And that's it about the write. Okay? Any question you want to ask? Any funny idea in your mind? And you think that, oh, something wrong or something not true. Okay? Yeah, give you something more interesting, okay? Although when I teach it, okay, I just based on the FAT32 specification to teach it, it will update FS info. And while we are setting up assignments in previous years, we find one interesting thing. Okay, what we're doing, we set this area, FS info, to all 0. Yeah, we try to do it. Okay, and I find that nearly all devices, no matter our Linux, Mac, even Windows itself, your card reader, your camera, all ignore it. Okay, this is 0, and all ignore. I don't know what happened. Okay, maybe Microsoft itself also know that this sucks. Okay, why follow us back? Okay, but don't do it. Okay, you assign you have to follow us back. Huh? All right, so this is a little things. Okay. Last milestone, deletion. Yeah, deletion. You always love to know why and how. What we can recover deleted file. Okay, so deletion is only 3 steps. First step, clear your linked list, right? Clean up the linked list. What is the meaning of clean up the linked list? You have a set of allocation, right? Very easy. You follow this linked list, you know the start of the file, you want to delete that file. Now don't do this. That file, use the red color. Huh? You can try it, no problem. Okay. I welcome you, okay, to join our Mac and Linux camp. You can go to our Unix side here. So you go to this linked list, set this linked list to all unallocated, free the space. Okay. Then what should you do? Suppose that we follow specification, FS info must be updated. So you return 3 blocks. So then you set 3 blocks here. I also update the next 3 clusters so that I have a longer consecutive days there. Now this is not a must to remember, not a must, because all devices outside the world, no one will care about this guy. Now what's next? Next is you finish the allocation, right? Because you lost the pointer already. You don't know what is your next cluster. Even the leading cluster, you also said that no, I don't need it anymore. So the allocation finished. What you still have is this guy, right? the root directory. So how to deallocate the root directory entry? Very simple. Set the first byte to a special value called 0xE5. E5, this special value. And it's done. This is condition. 3 steps. Deallocation, change FS symbol, change file and files directory entry structure. Only 1 byte change, okay? Then finish. Ask yourself, where are your data blocks? Well, where are the data blocks? Are they still there? Yes. Particularly that if you know that this is a new one, you just format it and you create that block, and that block must be able to be found. Bye bye. Okay. You know she's just sitting in a. Well, where am I? Oh, 3 steps. Still there. Now the problem is, where can you find that deleted file? Where can you find it? Yeah, use your imagination. How can you find it back? You know the data are there. The data are there. How can you look for it? Maybe I make the game easier. Let's say the case is you have a SD card, okay? And SD card only serve your Canon, your Sony or something. Canon, Nikon, whatever digital camera, only serve your digital camera. Okay? And you never take any movies. You only shoot photos using JPEG. To delete film pictures, how can you recover it? Huh?
You can scan through the data pool and then recognize the file header of JPEG.
Good. Very good. Okay, so his idea is ingenious. Scan all the data blocks. Find out JPEG header. The JPEG file has a so-called JPEG header, magic key, few bytes, so you can recognize this block belongs to the beginning of the JPEG. But a JPEG usually is a big one, right? Few megabytes. So what can you do about it? Yes?
Because our trading plan in the root directory just mark the first byte as that one. So you can first find the file with that one.
Okay.
And then you can go to that.
And that's a good idea. So his idea is you just delete the file, okay? So because you update the FS info, right? Update the FS info and you mark the leading data where you just believe that it is the thing that you just return to the system and hope that it is continuous.
No. Search through the FAT.
Go to the
and
FAT.
find the one start with EX.
Start the one here or here.
Sorry, next slide.
Next slide.
No. This one.
This one.
Sorry, next one.
This one.
You find
E5.
in root directory, find the one with start with E5.
Not E5.
I use it.
E5. This one. Right? You find this one, then what?
Then you would know it's deallocated.
Yeah, I know the allocation. Yeah, very good is the
But
allocation.
if it's still E5, then you know that place is not reallocated.
Okay. Then you go to recover that block. Okay, but again the same problem here. A JPEG file is fat. It's usually occupied
Not
several blocks.
recover, it means the file is still there, but you just don't know the place. But through root directory, you now know that file is there and where it starts.
But what if I'm at house? Maybe you seldom use a digital camera. Digital camera sucks, huh? It really sucks. You take some photos, right? It happens right in the folders. Right? I don't know what's the idea. Yeah. If you use cameras, very stupid. 100 camera something and 101 camera something, a bunch of sorry, generation camera. You guys use iPhones, okay? Yeah, follow me, okay? Is create subdirectories. Usually it's save the subdirectories. Okay? So if you're using the two camera, it's just same subdirectory. So the redirecting cannot happen. Yeah. So it seems to be a challenging game, right? How challenging is this? Because the link list is gone. The link list is gone, so you cannot know what is the allocation. So what we can do is just best effort. So do you understand what is the keyword best effort? Yeah. For normal Chinese guy here, also girls, you may try to transform it directly. Oh, best effort. Okay, so you perform best. You know, in English, best effort means I just can't do this. 准准的表示。Yeah, it means best effort. Okay, best effort 就是普通话我不懂啊，做过的错，做的错。Okay. Best effort. Okay, so best effort means you try, you fail. Okay, no guarantee that it is a successful rate. Okay, so how can we perform best in that best effort style? Wow, what happens? Shut down the air conditioning for 15 minutes and turn on again. COHK sucks. Okay. Now I skip ahead for a while. Now, first of all, if you find that you want to recover some file, remember the first step in the rescue. Hopefully, you're using a camera or using an iPhone or so forth. Then you can immediately eject the media. They pull it out. I don't know what is the way. Okay, you damage your phone, you go to the rescue car. Okay, it's up to you. Okay, yeah, it is doable. If it is a hard disk, remember the first step is to pull the power, no matter what. No matter what, pull the power plug. Okay, I don't know whether to shut down the entire home electricity. I don't care. Okay, yeah, just stop the power. Why? Okay, if it is a Mac, sorry, the damage the Mac. Okay, you can remove the battery, right? Why? Why have to pull the power immediately? Yeah, stop the update, stop the disk from updating. Okay, because you don't know what it's doing in the background, right? Just stop the update immediately. Then look at your, try to mount, we try to attach the disk as read only, and try to scan the directory. Let's say the directory is like this. This is not a root directory, it's a subdirectory, but you still know a part of your file name. I narrowed down my scope because it is always end with extension .jpg, right? Always .jpg. So you find that .jpg and then 0E5. Then it means something deleted. And inside this area, you have two very important information. One, the leading cluster location is still there. Second, the file size. Okay? So if you have the file size, you have the leading cluster information. Let's say the file size is smaller than one cluster. Can you recover it? Close to 100%. You can recover that. Okay? Because the handle, the leading cluster address is still there. Hopefully it's not being overwritten, and your file only takes that cluster. No link list is required. You disrupt a link list, I don't care. Right? I still know that I can recover that. But how about this? If it is bigger than one cluster, then we are there. We cannot do anything except for a few file type. Some file type, I don't know whether this is for interpreting or for some security checking, but they embed a checksum, like zip file. Zip file has a checksum. Let's say your zip file is corrupted, zip program immediately knows it. Okay, because you read the entire file, you find something wrong. Okay. Oh, by the way, do you know what is checksum? Google that. Okay. Yeah, if you don't want to Google that, wait for some time and take a security course. Okay. Security course will tell you what a checksum. Okay. Checksum is just a let's say 32 bytes. Okay. 32 bytes representation for the entire file. Okay, and if the file has a 1 byte size change, okay, that 32 bytes will 32 byte checksum change immediately. Okay, so this is the way to check whether the file is the same file that you received during the data transmission. Now here, how that checksum can help you. Let's say the zip file has checksum. Now, this is a crazy stuff, okay? And if you can only implement it given that you have a many power, many computer, fast computer clusters, and so forth, because you are doing brute force. Generate permutation of all the data block. Yeah. Why? Why is it all the data block? First of all, you don't know the order. Yeah, it's not always that allocating from a small address to big address. Sometimes it will skip, but sometimes it will reverse the order. So you have to generate the permutation. You know that the file size, right? The file size, let's tell you 10 cluster. Let's say it's 10 cluster. So you need this, find 10 DL data cluster, any 10, assemble it in any order, and check after you assemble it whether the checksum is the same. Okay? If the same, congratulations. Okay? If no, do it again. Okay? And you have a 1 TB hard disk. I don't know how many years you did it. Okay? But still, it is one of the methods. And last time I showed you the email that's sent to me from a BA, is it BA? Social science, EOS student, they asked me to recover the files. How can I be so successfully recover 1,000 files or something? I use a heuristic. The heuristic is I always believe that he saves JPEG file continuously. Let's say he hold a camera, just shoot and shoot and shoot and shoot, and never delete any file. I make this assumption. Then what can I do? Like this idea. I find the first JPEG header, then I continue to search for the next. And within that area, I treat that whole bunch of data between the two headers to be one file. And we generate that file back to a JPEG based on the file size, and then do the next one. Do the next one, do the next one. And using this simple trick, I recover 5 GB of data. Yeah, so it's only worse whenever it is something that you can predict, right? You tell me to recover a USB drive and you use it randomly. Sometimes you save MP3, sometimes you save some movies, okay? I cannot predict anything, right? But for that case, it is all our photos that I can do it. Okay? So this is about file recovery, okay? And we have a short conclusion. Conclusion is about FAT32 is so happen to be a real file system that we are still using. Very good. We use it for more than 20 years, close to, not more, close to 20 years. They are still, I miss something, the iPhone, Android, okay? Whenever you have SD card, it's never formatted as expect, right? So it will always be FAT32. Still it is using, and the file division, I give the question mark here. Yeah, you can have some ways to make it more clean, okay? A little more safely, okay? But nowadays, no one cares about this yet. Okay, now we will jump to the next chapter. For this index book allocation, I will leave it to the elite class, okay? Because the thing is not for human to read it, right? Wow, that's the big tree, right? The big tree gives you what is file size. The file size is approximately 4 TB file size, okay, for one file. Okay, so I will stop talking about file system. I missed one page. Okay, I give you a break and go back to this page. This page is to tell you some tools in order to save some studies, some demonstration, and about how to safely clean the hard disk. Okay? The main point about our thing that I didn't say, okay, is about the difference between NEFS and FAT. I say that NEFS and FAT, they coexist this allocation. No problem. Block size, they still do a block by block things. They don't have variable size block, okay? But with one exception. The journaling file system, when the journaling support. So what exactly is a journal? Journal is now all around in your system, okay? And let's take a look at this little story on how to describe a journal, okay? A journal is like this. Let's say you've got a boss, okay? You've got a boss to tell you to do a lot of things, Okay, usually when you face this, okay, you will miss some of the milestones, miss some of the tasks that you have to do it. Okay, so you will write down in a logbook. Okay, you write in a logbook and what are the things that you have to do. Okay, then what you do next, you really go to fulfill the promise. Okay, you promise the boss do the following, and while you are finished saying one stuff, after you finish, you will cross out this text from the logbook. Okay, so very natural, but suddenly you got a car crash, you lost all your memory. Yeah, but you didn't lose a logbook. Okay, so another man get hired by your boss. You know, someone lost their memory, so this way anymore. Okay, so your boss hired another guy, and another guy take your job and follow the logbook and know what are the tasks that have been done, what are the tasks that didn't finish, or in the middle of it. And when we map it back to operating system, this story is this force is the user program. I mean a process. A process uses a read-write system call, okay, to send commands to the operating system. Okay? Let's say you're doing some write commands, okay? And the write system call, while you are sending it to the operating system, it's not just one task. It's broken into a set of subtasks. Okay? And before those subtasks get done, it is written in what we call a file system journal, a small area of a hard disk. Okay? For me, on hard disk, you need something permanent. Okay? And that hard disk is that logbook, we call it journal. Okay, journal area. And while you're finishing some part of it, okay, you will mark in journal that what are the tasks that you have done, or you have taken some of the partial data there, so you write the journal, or you write all the data, so you destroy all the journals items. Okay. Now suddenly system crash, kernel panic. Okay. What is the meaning of kernel panic? You will get a system frozen, and you have to reboot the computer. Right? Now, usually, when you reboot a computer, I know when you guys are too young, okay? You never seen this, okay? When you put up, it tells you to scan this. Usually, you have seen this, right? But usually, they will give you time, 10 seconds time out. What should you do? Skip it. Skip it. Oh, don't skip it. Actually, what they are trying to do is to take a look at the logbook. Whenever you are not cleaning shut down the system, you reset the system has an obligation to look at the logbook, whether the logbook is empty or not. If you finish a task, you will clean the logbook so that it states that I have a finished transaction between your kernel and hard disk. Now, if the logbook contains something, that means what? That means you have some pending tasks didn't finish. The file system recovery tools or file system scanning tools, the scanner, usually when you scan it 1 hour, so we don't want to scan it, okay? But while they're doing the scan, actually it's go to the logbook to see whether the task can be repeatable or not. Let's say you are close to the end of the writing, just some little thing that didn't update the text, it do it for you, okay? So that you won't lose anything. Or the crash is too early. We didn't commit too many data into the hard disk and it crashed. Why not we roll back all the changes that was done by the partial steps? This is the journal. Okay, so with the journal support, you won't encounter things like you open a file, half of it is normal, half of it is corrupted. I have this experience. Okay, suddenly I got some panic, okay, and after you recover it, because during my time we don't have system journal, we don't have file system journal, so we will have a recovery. After recovery, half of it is my previous data, half of it is just Martian language, a bunch of things I don't know. Okay, but with the journal, you will end up with a completed task, or it roll back to the previous status. Okay, this is file system journal, and now every file system except FAT32 has a file system journal. And take a look here. It's not just a system support in the kernel, it's also a support inside the hard disk. The hard disk has an airplane space for the journal, as well as the OS know how to pack one system call. Let's say you issue a system call. What are the subtasks that you have to read or write to the journal? Okay? So this is a file system journal. And NTFS is a file system journal, so when you because you're too young, you never experienced it, okay? I upgrade from FAT32 to NTFS. Oh, no more crash, okay? I mean, those crashes are I can tolerate the loss, okay? And yeah, some other things, we didn't look deep into the file buffer cache, file system buffer cache, the kernel buffer cache, okay? About how it increase our speed, how it decrease our speed, okay? There's another things that we didn't cover, okay?